Hello, my name is Nir Lahav, and today I want to show you the relativistic theory of consciousness. So we have lots of interesting mysteries in physics, like dark energy, but consciousness is one of the most interesting mysteries in the universe. And, the question is how this gooey, messy, bloody organ can create our conscious mind. But first of all, we need to define what consciousness is. And I defined it with the canonical definition by Thomas Nagel from the 70s that consciousness is the answer to the question, what is it like? So for example, look at this cupboard. And we suspect that this cupboard has nothing that is like for him. There's nothing that is like to be discovered, exactly like there is nothing that is like for me when I'm under anesthesia. Only when I wake up out from the anesthesia, only then I have something that is like to sense the world, to feel or to think. I have something that is like to be happy or to see red. And so this is how we defined consciousness. And now we can see what is the hard problem of consciousness. So from my first person point of view, I have subjectivity. For example, I see an apple. But then when people look at my brain from the third person point of view, all they see are just neural patterns that represent the apple that I see. So this neural representation is a very complex representation, lives in a multidimensional state space. This is not the actual experience that I have of a 3D round-shaped red apple. So it means, because they are not the same, that we should find some mechanism in the brain, some function that create the experience out of this neural representation. But then we cannot find this mechanism in the brain. There is a gap here because everywhere that we look at the brain, all we see are just more and more neural patterns and more complex dynamics of them, but not the actual experience. So it seems that neuroscience alone cannot solve how the brain creates this conscious experience. So that's why we call it the explanatory gap or the hard problem of consciousness. And this is what we need to solve. Now, a bit more definitions. When we speak about these qualities of consciousness, what is it like to see the red, for example, we call it a quali or qualia. And then the set of qualia, we will define it as phenomenal consciousness. And as we saw, they are private and we cannot reduce them to the dynamics of the brain. So because we cannot reduce it, it means that we can think of a creature that might be identical physically to us, but just has no phenomenal consciousness. Because phenomenal consciousness, it seems it's independent of the dynamics and the physics of our brain. Philosophers call such a weird creature philosophical zombie. And those zombies, if they exist, are really weird because they do have cognitive system just like humans. So my zombie, my twin zombie, will have the same cognitive system like me, the same brains, same dynamics, same representations. So if I will give my zombie an apple, it can eat the apple and say, I eat a red apple and it's tasty. And because it has also representation of its inner state, then it can say things like, I have qualia and phenomenal consciousness. But we know that the zombies are just delusional. They have no phenomenal consciousness, only representations. There is nothing behind those representations. Try to think about Alexa. So let's say that I ask a song from Alexa and Alexa say, oh, I love this song. So I know Alexa doesn't really love this song. And this is more or less the idea of a zombie. Let's say that now a zombie is a very sophisticated Alexa. So the zombies has what David Chalmers call phenomenal judgments. They can do judgments about phenomenology without the phenomenal consciousness itself. Like this, I love this song. So it's a very weird situation with these zombies, and actually it reflects something about our own consciousness. There is a gap between the functional part of consciousness, let's say all the neural correlates of consciousness that we can measure, and the phenomenal part, the most essential part that we cannot measure. So what is going on here? This is exactly what theories of consciousness needs to solve. And we have lots of these theories. We can put them in a spectrum. In one side of the spectrum, you can have illusionism, that phenomenal consciousness is just an illusion. On the other side of the spectrum, you might have naturalistic dualism that suggests that we need to add phenomenal property to physics. Now, it really doesn't matter which theory of consciousness you like, because all of them actually assume the same thing. All of them assume that consciousness is an absolute phenomenon, and there is only one absolute answer for the question, does the creature have consciousness or not? And because of that, the observer can be delusional. So what will happen if we will assume otherwise? Let's assume now that consciousness is a relativistic property. It's observer dependent now. There is no one absolute answer for the question, does the creature have consciousness or not? It depends on the observer. What will happen now? So this is actually our approach, the relativistic theory of consciousness, and I would like to show you now how we can bridge the gap in a simple and non-paradoxical way. In order to do that, let's examine two examples from physics of relativistic phenomena. So first of all, let's start with constant velocity. So I will show you a video and let me know who is moving here. Is the lady inside the train is moving, or maybe the other train outside is moving? Actually, we cannot know. We need to wait until the end of this movie in order to see, oh, actually, it's the other train outside that moved. So this happens because because velocity is a relativistic phenomenon. And this lady in the train can do every experiment that she wants. She always will measure like she is at rest. So we cannot distinguish between resting state and moving in constant velocity. There is a symmetry here. Same laws of physics are in force in those two systems, and that's why it's relativistic. And that's why Bob will measure that he is at rest, although he is on a moving train with constant velocity. So he will say, I'm at rest, and you are moving, Alice. Alice on the platform will say, no, no, I am at rest and you are moving. Who is right? Both of them are right, of course, because velocity is relative now to the frame of reference that measures. But if they don't know it, then they will continue to argue about it, and Bob will continue to say, I'm at rest. And then Alice will say, no, no, I'm at rest, and you just have a delusion. And then Bob will counter-argue that, I do my experiment, I see that I'm at rest. So maybe I have just this private property that you cannot measure, and because that you don't see that I'm at rest. Of course, they are wrong here. Bob is not delusional, and he has no private property. It's just that velocity is relativistic. Now, what will happen if consciousness is relativistic? Well, it will be actually the same thing. So Bob will say, I have phenomenal consciousness, but you, Alice, has just neural patterns. And Alice will say, no, no, I have phenomenal consciousness, you have just neural patterns. And of course, they are both right, because now consciousness is relative to their cognitive frame of reference. Now, if they don't know about that, then they will continue to argue. And Bob will continue to say, I have a phenomenal consciousness. And Alice will say, no, no, it's just a delusion. And Bob will say, well, maybe I just have this private property that you cannot measure. But again, they are wrong now. There is no delusion here. Illusionism is wrong. But also there is no private property here. It's just both of them are different cognitive frames of reference that measure the same underlying reality from different points of views. So what we can learn from this example is that phenomenal consciousness, if it's not absolute and depends on the observer, then it means that it's not private or delusional, just relativistic. So now let's go deeper than that to the second example of Einstein equivalent principle. Here Einstein understood that there is equivalence between systems under gravitational field and systems under acceleration. So think about this spaceship that you can see here. This spaceship is on Earth, and the astronaut releases a ball from her hand, and the ball will fall because of gravitation. Now, what will happen if the spaceship is in space? And now there is acceleration of the spaceship upwards. And again, our astronaut releases her ball. Now the ball floats near her, but because she and the spaceship accelerate up, from her point of view, what she will see is that the ball actually goes down to the floor, exactly just what would just happen with gravitational field. So Einstein realized that, again, all the experiments will show the same results if you are under gravitational field or under accelerated system. And because of that, those systems are equivalent. And now Einstein did an ingenious idea. He inferred physical laws and phenomena from one equivalent system to the other. So we know that there is a redshift effect of light under accelerated systems, and then Einstein predicted that we will see the same effect under gravitational field. After 50 years, they showed that Einstein was right, by the way. So what Einstein used here is the relativistic principle, which means that if two different systems measure the same results, then because there is nothing above and beyond the observers, it means that there is equivalence between the systems, the same laws of nature are in force, and we can infer them between the system. So now let's do something similar, but first of all, let's assume broad physicalism. That just means that there is some kind of physical explanation for consciousness. It can be illusionism, it can be naturalistic dualism. So it's very broad and a weak assumption, but it can help us. So let's speak about the equivalence principle of consciousness. Now let's choose two observers, Alice, a human conscious agent, and zombie Alice. Let's call it artificial learning intelligent conscious entity, or capital letters Alice. Now, what we know about them is that they are physically the same, and they have the same reports, same dynamics. Because of that, every experiment that they will do, they will have actually the same results. It either can be what are their reports, what is their dynamics, representations, it will all be the same. So now we can use the relativistic principle, because here again, now we have two different systems measure the same results, Alice and zombie Alice. So because there's nothing above and beyond the observers, then there is equivalence between Alice and zombie Alice, and the same laws of nature apply to both of them. And we can infer now physical laws and the phenomena from one system to the other. So if Alice have phenomenal consciousness, also zombie Alice must have phenomenal consciousness. Or if you like, because of the broad physicalism, the same laws that explain consciousness in Alice system apply also about zombie Alice. And then it means that actually zombies cannot exist, because zombies now have phenomenal consciousness and have qualia. So now we can examine what is qualia exactly in the zombie system, because we didn't know that they have qualia. And after we do enough mathematics, we reach this equation that means on the right hand side, you see a qualia of xt. On the left hand side, you see phenomenal judgment representations. If you remember phenomenal judgments, like I see a red apple, so the representations of those phenomenal judgments, those are actually equal to the qualia, but in the frame of reference of the zombie. So mu here is the cognitive reference of the zombie. So now we need to take into account which cognitive frame of reference we are in. And only the zombie will measure now that his phenomenal judgment representations are qualia. So now we can gap the explanatory gap that we saw before. We asked, what is this function that takes us from the neural patterns to the actual experience? But now we understand that it's wrong question, because we didn't take into account the frames of reference. So now we have Bob that measure an apple, and Alice that measure that Bob only has neural patterns. And of course, that Alice will never measure the experience of Bob, because she's just in a different frame of reference. But what we understand, that there is an equality here, and that a third-person point of view and first-person point of view, they're actually the same, and they describe the same underlying reality, just from different frames of reference. Exactly like if we try to describe a coin, and you can describe either one side of it or the other, but not the whole coin at once. So this is exactly what is going on here. And because of that, there is no gap here, and we bridge the gap. The brain now doesn't create this phenomenal consciousness. It's just a matter of a physical measurement, and we need to be in the right frame of reference in order to measure it. So now the functional aspect and the phenomenal aspect of consciousness are the same, just again, it depends on which frame of reference we are here. So different measurements manifest different properties. That's why, from the zombie point of view, all of a sudden, the phenomenal judgment representations are actually phenomenal consciousness. So what is the difference here between the measurements of the third and first person frames of reference? Well, in the third person frame of reference, we use only our sensor devices in order to measure. And then what we can measure are physical substrates. So we measure with our eye, for example, and we can measure the neurons or the dynamics. But, and this of course is the third person point of view, but from first person frame of reference, the measurements are completely different. Now the physical measurement is, we have a representation and we measure it according to what is the role and the relation of this representation in comparison to other representations in the cognitive system. So this kind of measurements is completely different, and that's why it manifests a different kind of physical properties. So now we can understand what is phenomenal consciousness. It's a physical property manifested by measurement of phenomenal judgment representations according to the roles in the cognitive system. So every time that we will be in a frame of reference that can do this kind of measurements, we will have phenomenal consciousness. So it means, by the way, that relativistic theory of consciousness is not reductive materialism. It's a physicalist theory, but the brain here alone cannot create the conscious mind. For that, we need physics. Calculations are not enough. We need the physical measurement in order to do it. And different measurements can manifest different properties. And to finish, now also, because of the relativistic principle, it means that consciousness is not private anymore, and we can transform from one cognitive frame of reference to the other, and from first and third cognitive frames of reference. So for that, again, we did an equation and a transformation function that takes you from one qualia in one frame of reference to qualia in another frame of reference. And again, you can see it in the paper. And what we need to do in order to move frames of reference, we just need to change the dynamics of the cognitive system. And then it's a bit like, if you take Alice, that she's in a different frame of reference, and now she will go up to the train. So this is exactly what will happen if we will take the dynamics of the cognitive system of Alice, and we will change it to be like the dynamics of Bob. And now we can do a prediction here, actually, that if Alice and Bob will have the same dynamics and will actually share this dynamic, they would observe each other phenomenal consciousness. Now, it sounds like science fiction, but actually, this prediction might be true for that. But I think now that we need to finish, I want to thank Zachariah Neemeh that helped me with with the philosophical part of the paper, and we wrote the paper together. And I want to say that if you love this idea and or you know someone that will like this idea, please let me know. I would be happy to do my postdoc with you. Thank you very much.